Remember, we have over 200 bones in the body. We have lots of bones in the body. And we divide all of these bones up into sort of two groups. One of them is called the axial skeleton. There we go. The axial skeleton, when I see that, I always think of an axis, like structures can rotate around an axis. So the axial skeleton is everything right in the middle. So it's right in the middle, so it's going to be the skull, the vertebrae, the ribs, and the sternum. So it's just right here. That's your axial skeleton. This week in lab, we are looking at the axial skeleton. So skull, vertebrae, ribs, and sternum. The other group is called the appendicular skeleton. This is everything else. So these are the bones that you would find in the limbs and their girdles. A girdle is what holds your limbs onto the axial skeleton. So in this case, it would be the shoulders or the hips. Okay, so the appendicular skeleton is basically arms, shoulders, legs, and hips. Now, for all the bones in the body, we classify them 4 different ways by shape. We looked at these in lab last week. So a long bone is longer than it is wide. Can anyone give me an example of a long bone in the body? Yeah, so the humerus is one, that's your upper arm bone. The radius and the ulna would be one, the femur, tibia, fibula. Those are all long bones. We also have short bones. These are cube shaped. They are about as long as they are wide. Can anyone give me an example of a short bone? Carpals, which are in your wrists, and one other place. Tarsals, and that's it. Carpals and tarsals. Those are the only short bones in the body. We also have flat bones. These are bones that they'll have a curve to them, but if you feel them or look at them, they're really flat. They're not rounded. Can anyone give me an example of a flat bone? The what? The pelvis. Yeah, there are portions of the pelvis that are flat. What else? Yeah, the scapula, skull bones, ribs. Those are all considered flat bones. And then we also have what are called irregular bones. These are bones that have complicated shapes. So like the vertebrae, that's a great irregular bone. It's not really a short bone and not a flat bone, so we call it an irregular bone. So I'm going to walk you through the functions of the bones in our body. So your bones do a lot more things than you probably think about. One is that your bones do provide you with support. They are the framework for your body. I always think, if you look at that skeleton, it would be sort of like the scaffolding for a house, right? If you've ever seen a house being built, they start with sort of a framework. And that is what the skeleton is providing you, is providing a framework for your whole body. It also supports your organs and protects your organs. So great examples of protection would be like these cranial bones up here. They protect that soft nervous tissue that sits inside this cranial cavity. Right? So you have this nice bony protection around there. Also, your spinal cord is going to run down through the vertebrae. There's a little hole in the middle. And so your spinal cord is completely encased by bone. You've got some important organs that sit up here in this thoracic cavity, like the heart and the lungs. They're all nice and protected by bone. So your bone does provide this nice protection. The third one, movement. Your bone without muscles can't move. However, I want you to think about skeletal muscles. Skeletal muscles get their name because they attach to the skeleton. So your skeleton, your bones act like levers that a muscle can pull on. So an example might be, think of your bicep muscle. The bicep muscle, it's gonna run from the top of the humerus all the way down. It's gonna cross the elbow and it's gonna connect down at the radius and the ulna. When that muscle contracts, you get this movement. You get flexion of the arm. So the muscle is pulling on the bone. All your skeletal muscles are attached to a bone where you get some kind of movement. So your skeleton can act as a lever that your muscles can pull on. Your skeleton also acts to store minerals. Now it can store a lot of different minerals. The one that we usually think about the most is calcium. So remember, what do we need calcium for? Everything. We need it for muscles to contract, nerves to fire, glands to secrete, cells to divide. You need calcium for every physiological function that's happening in your body. And as we go through physiology in all of these different organ systems in anatomy 1 and in anatomy 2, you're going to see calcium over and over again playing a role in the physiology. So calcium is essential. We have to have it. However, your body looks at your bones as a place to store extra. So if you have extra calcium, at any point in time, your body goes, yeah, I'm going to store it. And you store it in your bones. And one of the byproducts of putting calcium in a tissue, we just talked about, it makes that tissue hard. So when you store extra calcium in your bones, it makes your bones nice and hard, okay? If there's ever a time where you do not have enough blood calcium for all of those functions I just talked about, you're gonna pull calcium from your bones. You will leach it out of your bones. You will literally break your bones down so that you can liquefy the calcium and put it in your bloodstream. So your heart can contract and your nerves can fire and your muscles can contract. And then lastly is blood cell formation. This is a little bit weird, but if y'all remember when you looked at that frozen beef bone last week in lab, there are hollow spaces in that bone. So in the diaphysis, the shaft of a long bone, there is a medullary cavity, a hollow space. In spongy bone, there are little holes all over in that. And typically, especially in babies and young children, anytime you have a hollow space inside your bone, it is going to be to store red bone marrow. And red bone marrow is the site of what's called hematopoiesis. Hematopoiesis is blood cell formation. So this is where you are going to be making red blood cells, white blood cells, and platelets. Now, as you get older, you become an adult, you don't need quite as much red bone marrow. So you guys looked at a beef bone last week, and in the medullary cavity, it was not red bone marrow. What was in the medullary cavity? It was like butter. What do we call that? Yellow bone marrow. Yellow bone marrow is just fat. So you could tell that the beef bone that you guys were looking at was an adult beef bone because it had yellow bone marrow in it. So in your bones, if we were to cut your bones and look inside that medullary cavity, it would be filled with yellow bone marrow, not red. But like my son, who's only 9, he's still actively growing and getting bigger. His medullary cavity is filled with red bone marrow. He's making those red blood cells. And he's got to have more red bone marrow than an adult because he is still growing so fast.